to Gore Math Circle's MathCounts training. This is session 8 of a 12-part series, so if you haven't watched the other videos, go ahead and watch those. And when you're done with that, come back to this one. My name is Mugil Shanmugam, and I'm going to be presenting all these videos for you guys. So let's get right into it. So session 8 topics. What are we going to be learning today? So today we're going to be covering the following broad topics: permutations of digits and the sum of n-digit numbers, arithmetic sequences and common terms, and absolute value and inequalities. And underneath all these topics, obviously, we have some subtopics like collection of useful information, so just some basic knowledge that you need to know, formulas, the definition and properties of absolute value, and we're going to be doing exam problems for each of these topics so we know how to do them. Okay, so let's get right into it. So basic knowledge for permutation of digits. So the first thing we do know is for each of these digits in a number, when we're asked to find the number of possibilities, we have 10 digits to select from. So if I'm making a 3-digit number, my first choice has only 9 possibilities because the leftmost digit cannot be a 0. After that, I have 10 possibilities for the other 2 numbers because it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there's 5 odd digits and 5 even digits that I can choose from when I'm making a number. The smallest digit of a particular digit number set is at 1 followed by zeros. The largest number is continuous 9s. So for example, the smallest 3-digit number is going to be 100, 1 and 2 zeros. The largest 3-digit number is going to be 999, continuous 9s. So this is just a quick little trick you can keep in mind when you're asked to find the largest or smallest number that relates to a particular set. Any 2-digit number or greater, so 2-digit number, 3-digit number, 4-digit number, and so on, is greater than the product of its digits. So that's pretty self-explanatory. If you multiply the digits of a number, and if it's above a 2-digit number, so it's greater than like 10, then this should hold true. Basically, the number itself should be greater than the product. If you multiply 2 numbers of the same digits, like 2 3-digit numbers, the product will have at least 2n minus 1 digits and no more than 2n digits. So if I'm multiplying 2 3-digit numbers, I should have at least 5 digits, but no more than 6 digits. So this is just a quick trick you can use to make sure, oh, am I doing my multiplication correct, or am I making a mistake somewhere? So these tricks will just help you keep sure that you're on the right track. If you multiply a number with m digits with one of n digits, the product will have at least m plus n minus 1 digits and no more than m plus n digits. So similar to this, if you multiply one with 2 digits times one with 3 digits, you know that it has to be at least 4 digits, but no more than 5 digits. If you're given repeated digits and asked to find a number, so let's say I'm given, you have 2 2s and 3 3s. Find how many possible 5-digit numbers you can create. So based on that, I'd put a 5 over here for my n. For my first number is going to be my r, so that's 2. My second possibility I have is 3. So 2 factorial times 3 factorial over 5 factorial on the top. So like that, you can use this formula, and we'll be going over it on an exam problem that you do using this, just so you know how to use it. So the number of n-digit numbers. So there are 9 times 10 times 10, 900 3-digit numbers, half even, half odd. How do we get to this? So the first digit has 9 possibilities. It can't be a 0, but it can be anything else. The second digit has 10 possibilities, and the third one also has 10 possibilities. So based on that, I figured out there's going to be 900 3-digit numbers. Half will be even, half are going to be odd. Now there's going to be 9 times 9 times 8, 648 digits if digit repetition is not allowed. So if I can't have a number like 222, then that's going to reduce the numbers that I have, right? So based on that, I can figure it out, because my first one is going to be 9 because it cannot be 0, so I have 9 possibilities. The second one is also going to be 9 possibilities. Normally it would be 10 possibilities, but since one number is already taken, I have 9. Finally, the third one's only going to have 8 because I cannot use any of the numbers I already used, so I only have 8 possibilities left rather than the original 10. So that's how we found that we're going to have 648 3-digit numbers if digit repetition is not allowed. There's going to be 328 even numbers and 320 odd numbers. Obviously, don't memorize this, just know how you can find it. So if you understand how we're going to use the 9 times 9 times 8, you can figure this all out by yourself. Similarly, there are 9 times 10 times 10 times 10, 9,000 4-digit positive integers, so just 4-digit numbers you could call them. And there are 9 times 9 times 8 times 7, which is 4,536 numbers if digit repetition is not allowed, and these are 4-digit numbers. So sometimes you'll be asked to find the sum of n 3-digit numbers. So you can use this formula to make it quicker. So if I'm asked to find the sum of 3-digit numbers or 4 3-digit numbers, what I do is I add up all the hundreds digits and then I multiply that times 100. Then I add up all the tens digits and I multiply that by 10. And then finally I just add up all the units digits and then I add all that together. So this is the same idea as place value, right? Because if I have 100 digit, it should be multiplied by 100. So I can just add only these digits and then I can multiply them by the corresponding place value, and that makes my life so much simpler. So you can use this formula. Likewise, we can expand this if we're going to be doing 4 digits or 5 digits. We just need to add one more at the front that says 1,000 times the sum of the 1,000th place, right? So likewise, we can expand this by adding the sum of m digit times 10 to the power m minus 1. So the sum of m digits, so like the sum of the thousandth digits times 10 to the power, so 1,000th would be 4, right? 4 minus 1, 10 to the power 3. For example, the thousandth place would be the 4th digit if you're going to use it, so then you could just plug in, and based on that, you could derive a new part of this formula. And based on that, if you add it all together, you could find a sum of n 4-digit numbers and expand it to 5-digit numbers, 6-digit numbers. So based on this, you can just make your addition much simpler. Okay, so let's move on to a quick sample problem. So if I'm given the digits 3, 9, 5, 6, and 2, how many different 5-digit numbers greater than 41,000 can you form? And this is from MathCounts. So this is an actual real problem, so we're going to try to solve it. So pause the video here, go ahead and give this problem a go. Okay, so hopefully you tried out the problem. Let's see how we can solve this. So our first digit can only be a 5, 6, or 9. The reason for this is because it must be greater than 41k, right? If it has to be greater than 41,000, well, what that means is you can't have a 3 as your first digit, you can't have a 2. So I only have 3 possibilities for the first one. Now, I've already used one of my numbers when I come to my second digit. So one of these numbers is gone. I only have 4 possibilities left. Then I have 3 possibilities left for the next digit, 2, and 1. Remember, each time I'm losing a possibility because I've already used a digit. And here it says using each digit only once. So because of that, I'm losing a possibility each time. So originally I started out with 5. Now I'm going to go to 4. Then I'm going to go to 3, 2, and 1. Now you should recognize that this sounds like a factorial. So that's how we've written out here. We have 3 possibilities for the first one because we can only use these 3 digits. Then after that we have 4 possibilities, 3 possibilities, 2 possibilities, and 1 possibility for each of the digits in descending order. So 3 times 4 times 3 times 2 times 1 is 72 possible 5-digit numbers. You could have also written this as 3 times 4 factorial, either way. But that's how we figured out that there's going to be 72 possible 5-digit numbers. So remember, you just want to keep track of how many possibilities you have and make sure to read the question carefully. Is it using each digit once, or is repetition allowed? How many different 5-digit numbers? Is it 5-digit numbers, 6-digit numbers? You want to keep track of all that information. And make sure if they have any caveat like greater than 41k or greater than like 52k, make sure you're keeping track of that because that's going to change your problem. Okay, so now we're going to move on to our arithmetic sequences. So an arithmetic sequence is one that has a constant difference between terms. So the common difference D is a subscript n plus 1 minus a subscript n. So basically, a subscript n, this could be my first term, and this could be my second term. So the second term minus the first term is going to give me my common difference. So if I had a sequence like 2, 4, 6, 8, 7, 2, 4, 6, 8, 10, right? So my common difference there is 2. I'm incrementing by 2 each time. That's all the common difference is. Now the nth term formula is how I'm going to find the 10th term of that sequence, or the 11th term of that sequence. So here a of n is going to be my nth term. So instead of n, I would substitute whichever term I want. If I wanted the 11th term, I'd use 11 here, a subscript 11. So it's going to be equal to a subscript 1, so my first term, plus n minus 1 into d. So here, I know some people would write it as a subscript 0. Here, I've written the first term as a subscript 1. So just be aware of that. So here, what I'm doing is the first term plus n minus 1. So my nth term minus 1. So like, if this is the 11th term I want to find, 11 minus 1 into d, common difference. And based on this, you can find your nth term, my 11th term. Now the sum of n terms in the sequence, well, this is the sum. So s is my sum. That's just going to represent my sum for now. It's a variable. And here I have my first term plus my nth term times n over 2. Here, nth term simply means the final term of the sequence. So how many terms does the sequence have? That's what I'm going to write for n. And here, my last term, I'm going to fill in here to add with my first term. And this is all going to be divided by 2. That's a simple formula that we're going to be using. Make sure to know these. You may want to memorize them or just know how to find them, because the sum of n terms and the nth term formula are going to be invaluable whenever it comes to anything to do with sequences in general. Now, here's one important point. Arithmetic sequences are not the same as geometric sequences. So arithmetic sequences have a common difference, right? They're added by the same number each time. While geometric sequences have a common ratio, they're multiplied or divided by the same number each time. So make sure to keep those two separate in your head. Okay, so here's some more formulas that we can use when we're given an arithmetic sequence. If A, B, and C are 3 consecutive terms in an arithmetic sequence, so A is the first one, B is the second one, C is the third one, B is going to be equal to A plus C over 2. So if I know my first term and my third term, I can find my second term pretty easily by using this formula. If n plus n is equal to p plus q, and these are all positive integers, then I have this formula. A subscript m plus A subscript n is equal to A subscript p plus A subscript q. So these are just different terms in the sequence, and so let's just say this is m is 1, n is 2, and then here I have something that makes that equivalent, right? Let's just say, I got 3 over here. Let's just say that p is 3 and q is 0. So what this is basically saying is if I use the first term and the second term, and here I use the 0th term, and I use the third term, then when I add them all up, it should all be equal. So both sides of the equation should be equal. This is just simply just plugging in different numbers and different terms and just making sure that both sides of the equation are equal. Finally, here we have 2 more formulas. So here it's A1, so A subscript 1 plus A subscript 2 plus A subscript 3 plus A subscript 4, plus A subscript 5 is going to be equal to n. Then I can solve this, right? A subscript 3 is equal to n divided by 5. 5 terms, I'm dividing n by these 5 terms, or just the number 5 here, to find my third term in the sequence. So this is helpful if I'm given the first 5 terms and I'm asked to find what is the third term. Like I'm given 1, 2, 3, 4, and I'm asked to find the third term. Or if I know the sum of the first 5 terms and I need to find the terms in the sequence. Similarly, here I only have 4 terms. So I don't have this A5 anymore, I only have it up to A4. So here my formula changes to A2 plus A3 over 2 is equal to n over 4. So once again, if I'm given the sum of the first 4 terms, then I can use this formula to figure out my first and second term, or at least their sum, which I can later use to find out more things. So again, these are some helpful formulas that you can use if you're asked to find different things when it comes to arithmetic sequences. So just know these. Okay, so here's a sample problem. Find the sum of the following numbers: 3, 7, 11, 15, 19, all the way to 199. So here's a tip: don't add this manually, it's going to take forever. You want to find your pattern here, and then you're going to have to find your nth term, or like the number of terms in the sequence, and based on that you can find your sum. So go ahead, pause the video, and try to solve this one. Okay, so hopefully you solved the problem. Let's go over the answer. So the common difference is 4. To find the number of terms, we can transform our formula to find the nth term, right? So here's our nth term, and this is going to be equal to the first term plus n into 1, so the number of terms minus 1 into d. So we can transform this based on what we know. We know that the last term in the sequence is 199, and we're trying to find what n is. And this is going to be equal to the first term, so 3, plus n minus 1 times d, and here d is 4. Why? Because 3 plus 4 is 7, 7 plus 4 is 11, and so on. So here I've set up an equation like this. 199 is equal to 3 plus n minus 1 into 4. It's a linear equation. You can solve that, and once you solve that, you get 50 as your answer. So what this is basically telling you is that there's 50 terms in this sequence. Now we can plug this into our sum. So our sum formula is the first term plus the nth term into n over 2. So my first term, 3, plus 199, my last term, times 50, because there's 50 terms, over 2. And when I solve that out, I get 5,050. So that's how I found the sum of this. Don't add it all up. I know some people just add it up rather than using the formula, but it's actually quicker to use the formula. So make sure that you know how to apply this formula when you're given a problem like this. And again, our answer is 5,050. Okay, so now let's go on to absolute value and inequalities. This is like our last topic for today. So here's some properties you need to know with inequalities. The first one is the transitive property. So if A is less than B and B is less than C, then A is less than C. Pretty self-explanatory, right? So if A is less than B and B is also less than C, then A has to be less than C. Here's the additive property, which is if A is less than B, then A plus C is less than B plus C. And obviously we're assuming that this is all for positive integers. Multiplication is if A is less than B and C is greater than 0, then A times C is less than B times C. Because A is less than B, so AC is going to be less than BC. Another multiplication one, if A is less than B, but this time C is less than 0, then A times C is going to be greater than BC. So these, you shouldn't have to worry about memorizing them because they should just come naturally to you. You can experiment with these and you can derive them if needed. Don't forget to change the direction of the inequality when multiplying or dividing by a negative number. So always remember this. Many people mess up this, so make sure that you need to change the direction of the inequality. If it's greater than, change it to less than, and if it's the other way around, just change it if you're dividing or multiplying by a negative number. So absolute value, you've probably heard of it already, but absolute value is always positive, and it's the distance from 0 of a number. So if I'm given a number and asked to find the absolute value, they're asking, how far is this from 0 on a number line? That's one way to think about it. So here are some properties of absolute value and intervals. So if A is equal to B, or A is equal to negative B, then your absolute value of A is going to be equal to absolute value of B. So if A and B are equal, or A is equal to negative B, your absolute values are going to be equal. And our absolute value is always going to be positive because this is a distance, it's not a negative value. So there's going to be 3 open intervals, right? Open intervals, usually they're going to have these normal brackets, parentheses. And what this means is from A to infinity, this is an open interval. From A to B, this is another open interval. Finally, from negative infinity to B, this is an open interval. Now we have 3 half-open intervals. Half-open intervals are going to have a half, so they're going to have a square bracket, and they're going to have a curly bracket. A parentheses. And basically what these mean is parentheses mean that it does not include the value right here. So A to infinity here, it represents the area in between the two, but it does not include infinity or A. Similarly, A to B, this interval does not include A or B in the solution because it's using these parentheses. However, if it uses a square bracket, that means that B is included in the solution. So just make sure to make that distinction. So 3 half-open intervals are going to have one inclusive and one exclusive, right? So that's why we got A. So A is included in the solution region to infinity, but infinity is not included. Here, A to B and B is included. And here, negative infinity to B and B is included again. So these are half-open intervals because we have one normal parentheses and we have one square bracket. And a closed interval has both square brackets, so it is inclusive of everything. Here it's A to B, so this includes both A and B in the solution region and the place or the area in between the two. So make sure to know how to use this interval notation because this is how we're going to be representing some of the answers we get in our equations when it comes to absolute value. Okay, so here are some more properties of absolute value. So absolute value of A has to be greater than 0. That's pretty self-explanatory, right? Absolute value is always positive because it's just a distance. So again, absolute value of negative A is just going to be absolute value of A, which is A. Now absolute value of A times absolute value of B is going to be equal to the absolute value of AB. You can just multiply the two. Here, the absolute value of A divided by the absolute value of B is equal to the absolute value of A divided by B. So these are just some simple properties. You've probably seen them in like different situations. We're just applying them to absolute value. And here B cannot be 0 or that's undefined. And here this is called the triangle inequality. And this basically says that absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. So here's some quick formulas. You should be able to just think of these on the spot. Don't memorize them. You'll learn them as you go and you keep working with them. Okay. So let's move on to equations. So for real numbers A, B, and C, assume that the absolute value of x minus A plus the absolute value of x minus B is equal to C. And here, x minus A and x minus B is how far x is from A and B. So x minus A, that's the point x minus point A, the distance in between the two, basically. So the distance in between x and A plus the distance in between x and B is going to be equal to C. Now, if the distance between B and A, so here we are talking about the distance between x and A. Here, if the distance between B and A, so absolute value of B minus A is equal to C, so the distance between A and B is equal to C, and the distance between this equation is also equal to C, then this equation has infinitely many solutions. And I'll show you a number line with this in a second. If the absolute value of B minus A, so the distance between B minus A, is less than C, then there are going to be two solutions. X can be to the left of A or to the right of B. So it has to be on one of the extremes. And finally, if B minus A, absolute value of B minus A is greater than C, then there are no solutions. No matter where X is, the equation will not hold true. And I have number lines for these, which I'll show you in just a second. So what this is saying is if we have the distance between A and X and the distance between B and X, and we also know the distance between the two, A and B, then we can create different equations and find out how many solutions we have in each case. So here's a number line picture. Here's the first situation, right? When the distance between A and B is C. Here, if you could see it, the distance between X and B and the distance between X and A, when you add them together, you get C. So this equation has infinitely many solutions. Wherever I move X on the number line in between A and B, I will get infinitely many solutions. Here, C is not equivalent to the distance between A and B. So the distance between X and B, right? This distance plus this distance is going to be greater than C. So it doesn't meet the condition that we want. We want this distance between X and A plus the distance between X and B to be equivalent to C. So this means that there are going to be no solutions because C is too small. Here we have the case where we have two solutions, right? Here C is between A and B, right? It reaches that distance. So here X can be on either side in order to make this inequality work. If we see here, it says the distance between B and A is less than C. So that's how we get the two solutions. So basically here, I don't know if you can really see that, but basically C is bigger than both A and B. It expands further than the distance between them, and that's why X can be on either side of the number line to get your solution. So don't worry if it doesn't make too much sense right now. As you look more at the number lines and kind of solve problems with them, it makes much more sense. But just know that this distance C is going to be equal to X, the distance between X and A, and the distance between X and B. Now, in some cases, A and B, the distance between them is going to be perfectly C. In other cases, it's going to be smaller or bigger. And based on that, we have different solutions. Sometimes we have infinitely many solutions, sometimes we have no solutions, and sometimes we have two solutions, one on either extreme. So we're going to do a problem that involves all of this. So find all the integer solutions to absolute value of x minus 2 plus absolute value of x minus 3 is equal to 1. MathCounts competition. So you may know another way to do this using cases. I'd prefer if you use one of these methods to solve it, just so we can go over this concept. So go ahead, pause the video, and try to solve this problem. Okay, so hopefully you pause the video and you try to solve it. Let's go over the answer. So our critical points are 2 and 3. How do we find this? Well, we solved by setting each expression inside the absolute value equal to 0. So x minus 2 is equal to 0, x is equal to 2. X minus 3 is equal to 0, x is equal to 3, right? So here are my critical values, 2 and 3. So we can set this up on the number line as a and b, 2 and 3. Now, here, our original equation is already in the form x minus a plus x minus b is equal to c. If we look back here, this is an equation, right? X minus a plus x minus b is equal to c. And here, it's x minus 2 plus x minus 3 is equal to 1. So my c is 1, and my a is 2, my b is 3. So that's how I figured out all of that. So now we need to find what is the difference or the distance between a and b. So my a is 2 and my b is 3. The distance between the two is 1. So I know that my distance between a and b is going to be 1. Well, what is my c value? Well, if we look back at the equation, my c value is also 1. So we can conclude that this is the same as this case, when the distance between b and a is equal to c. So the distance between b and a here is 1, and c is also 1. So we have this case, where there's infinitely many solutions. Now, read the question, however. It says, find all integer solutions. So, as we said, there are infinitely many solutions, but has to be between a and b. So any solution in this region between 2 and 3 works. However, they're only asking for the integer solutions. Therefore, the only two solutions that are integers are 2 and 3. All the numbers in between are going to be decimals and they won't work as integers. So only 2 and 3 are my solution, and it's because it's going to fit this exact pattern, right? Based on that, any x in here is still going to make this equation true. Even if x was over here, the distance between a and x plus the distance between x and b is going to be equal to c. So based on that, that's how I discovered that I know that there's going to be infinitely many solutions as long as it's between 2 and 3. However, they asked for integer solutions only, so only 2 and 3 are integers in this region. So my answer is going to be 2 and 3 because they're the only integer solutions that meet our goals. So again, we just use this number line and we use this concept to break our equation down into the same form, and then we just solved. So practice drawing out these number lines. Maybe you could try, like if you have the equation, practice drawing them out without looking at the slide, and this can help you get better practice in understanding the concept. Go ahead and try more problems about absolute value if you have the time. Search them up, and this is very good practice for these types of problems. Okay guys, thank you for watching. Please like and subscribe if you enjoyed the video, and leave a comment with any questions, and I hope you guys have a good one. Bye.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!